Okay, good morning. First chapter, first year is units and dimensions. So that is a basic chapter and it is related to all the chapters of first year and second year. It is not a particular separate topic. It is related to all the first year topics, second year topics. So you must know about the physical quantities, their units and dimensional formulas and the relations between them, etc. This is units and dimensions. It may contains 2 to 3 parts. We can check it. First of all, yesterday in the introduction we discussed what is physical quantity. Physical quantity is which is able to measure is called physical quantity, and the physical quantities are two types. One is fundamental physical quantity, second one derived physical quantity. Fundamental means the physical quantities are independent of other physical quantities. They are called fundamental physical quantities. Example, length, mass, time. And derived physical quantities means the physical quantities which are derived from fundamental quantities are called derived physical quantities. Many are there: velocity, force, momentum, work, power, energy, magnetic flux, magnetic induction, current, electricity, current by area, that is current density, potential, capacitor, etc. But first the taken fundamental quantities only three: length, mass, time. And length is measured in centimeter, mass measured in gram, time measured in seconds. That is called CGS system. They introduced one system to measure the units, that is called CGS system. These are the units. Length, mass, time are fundamental quantities. They are measured in different units. We selected centimeter in for the length, gram for mass, second per time. That is called CGS system. Length is measured in meter, mass is measured in kilogram, time measured in second. That is called MKS system. If the length is measured in foot, mass measured in pound, and time measured in seconds, that is called FPS system. So we have three systems to measure the units earlier, because there are three fundamental quantities: length, mass, time. So we have three systems are in use. Later one new system is introduced, that is called SI system, System of International Units system. Nowadays everyone following that one only. According to that new system, there are seven fundamental quantities: length, mass, time, temperature, electric current, luminous intensity, and amount of substance. So there are seven fundamental quantities. Fundamental quantities means which are independent of other quantities are called fundamental quantities. In a new system known as the SI system, there are seven fundamental quantities: length, mass, time, temperature, electric current, luminous intensity, and amount of substance. So in SI system there are seven fundamental quantities: length, mass, time, temperature, electric current, luminous intensity, and amount of substance. What about their units? Unit is meter, mass kilogram, time second, temperature Centigrade, Fahrenheit, Kelvin, Reimer, different scales are there. In that, Kelvin is the SI unit of temperature. Electric current is measured in ampere. Luminance intensity measured in candela. And the amount of substance measured in mole. They thought these seven are enough. These are the fundamental physical quantities. Later, some other quantities difficult to measure. Those are taken as supplementary quantities. So we have two supplementary quantities. These are the fundamental quantities. And the two supplementary quantities we have they added. They are plane angle and solid angle. Plane angle measured in radian, solid angle measured in steradian. Plane angle, solid angle. Okay, so this is about SI system. There are 7 fundamental quantities and 2 supplementary quantities. These fundamental quantities having particular symbols. Length is represented by L, mass is by capital M, time is by capital T, temperature by K or theta, and the current is represented by I, R, A, candela, CD, and mole amount of substance represented by MOL, plane angle represented by RAD, radian, ST, RAD, or SR. SR means steradian, SR. These are the symbols. By using these symbols, we can arrange, we can represent other physical quantities. That expression showing the a physical quantity by raising the powers of fundamental quantities is called dimensional formula. So we can express any other physical quantities in terms of these symbols. That means derived quantities by using these symbols, that is called dimensional formula. For example, velocity is there, displacement by time. Displacement means length, time means t. So L1 t power minus 1 is the dimensional formula for velocity. Like that we can represent derived physical quantities by using these symbols. That expression is called dimensional formula. In the first part, what you have to do is we have to separate physical quantities into 4 parts. One is mechanical physical quantities. Mechanical means which are in motion in straight line, motion in plane, laws of motion, moment, the rigid body dynamics, gravitation, etc. So those all physical quantities are called mechanical physical quantities. Second one, thermal physical quantities. That means which are in heat part. That means the temperature, heat energy, thermal capacity, specific heat, latent heat, gas constant, universal gas constant, Boltzmann's constant, etc. Again, next we have in magnetism one separate chapter. Magnetic physical quantities, pole strength, magnetic moment, and intensity of magnetization, intensity of magnetic induction field, magnetic flux, etc. And one more part is there, that is electrical physical quantities. That means temperature, electric current, potential, capacitor, charge, etc. So physical quantities are classified into 4 groups. What you have to do is you have to note down the dimensional formulas. First, physical quantities, mechanical physical quantities, their units, their symbols, their units, their dimensional formula. So that is you have to make a tabular form. 4 tabular forms will come. So mechanical physical quantities. Serial number, physical quantity, formula for that, SI unit, dimensional formula. So these are the columns. So like that, mechanical physical quantities, next electrical physical quantities, next thermal physical quantities, and next what next? Magnetic physical quantities. So you have to make tabular forms like this. Continuation. Mechanical physical quantities means example velocity, acceleration, force, everything will come. And next one more important point. The physical quantities having same dimensional formula are called isodimensional quantities. Isodimensional quantities means they have same dimensional formula. For example, pressure, stress, they have same dimensional formula. You just collect the physical quantities belongs to isothermal. That means isodimensional, same dimensional formula quantities you collect at one place. Then use only one dimensional formula one time. Like that, we have to fill this table. We can give it printing manner. We can send the soft copy. Just you copy one time. So without wasting of time, you have to note down. You have to write it. All physical quantities and the formula and the dimensional formula and SI unit and a number of times you have to practice. Okay. And the next step, what is use of dimensional analysis? What are the uses? We can check it. Uses. 1. We can obtain the relation between SI unit and CGS unit of a physical quantity. That is first one. We can obtain by using dimensional analysis. We can obtain the relation between SI unit and CGS unit of a physical quantity. For example, what is the relation between Newton and dyne? While doing these problems, you should be perfect in dimensional formulas. Okay. So Newton dyne relation is required. So write down Newton and dyne. Both are units of force, SI unit and CGS unit. Then dyne means write the dimensional formula of force. M1 L1 T power minus 2. This one also M1 L1 T power minus 2. Now you write down SI units of these dimensional formulas. kg, meter, second power minus 2. Gram, CGS units, centimeter, second power minus 2. Now second power minus 2 cancelled. Now we convert kilograms into grams. That means 1 kg is 10 power 3 grams. 1 meter means 100 and 10 power 2 centimeter divided by gram centimeter. Now gram cancel, centimeter cancel, we get 10 power 5. Therefore 1 Newton is equal to 10 power 5 dynes. 1 Newton is equal to 10 power 5 dynes we got, and this one we got it by using dimensional analysis. That is use of dimensional formula. Second one, we can verify the correctness of the given expression. Is it right or wrong? We can verify. For example, time period of pendulum 2 pi root of L by G. LHS time period ante T. RHS right hand side. 2 pi is a number and root of L by G. So we write down root of L ante length L, G means L1 t power minus 2. So L cancel, then we get a root of t square, that is